Girls and cougar parents, today we're going to start Unit 8, which deals with volume of cylinders, cones, and spheres. But before we dive into this, we need to do a little review, a review on area. Okay, and we're going to take a look at the area of some basic polygons as well as some irregular shaped polygons. And if you have an irregular shaped polygon, you just need to decompose it into its regular shaped polygons and then add up all the areas to get the total area. Let's take a look at a few sample problems right now. Boys and girls, let's look at our area practice or review worksheet. Let's go to number 1. It says the area of the rectangle is 48 square centimeters. What is the area of the shaded triangle? Show all work. Well, I know that area is equal to base times height. I know that the area is 48 centimeters squared. What I don't know is what the base and the height are. Now, I could have numerous combinations. I could have 2 and 24. I could have 6 and 8. 2 times 24 is 48. I could have 6 times 8 is also 48. I could have 4 times 12. Okay, it doesn't really matter because I know that this triangle is going to have the same base as the rectangle, and it's going to have, if I drop my perpendicular line, it's not too perpendicular, let's just say it is, I drop a perpendicular line, it's going to be equal to the height of the rectangle as well. And I know that my area formula for a triangle, area is equal to base times height divided by 2. So I know that whatever combination I have, whatever these dimensions are, it's going to equal 48. So it's going to end up equaling 48 divided by 2, and 48 divided by 2 is 24 centimeters square, because every triangle is half of a rectangle. Okay, let's jump down to number 5. Here we got some circles that we're working with, and we need to find the area of the shaded areas. This, at a quick glance, this problem over here looks like it's a cutout problem, but really it's not. They're just using this square to give us the diameter. Okay, the diameter all the way across from one side of the circle to the other through the center is 24. It'd be the same as the base of the rectangle. They're trying to show us that. Therefore, the radius would have to be half of that, which would be 12. Okay, so now I have all the information that I need to solve this. I know that the area of a circle is pi r squared. Pi is approximately 3.14. My radius is 12, and I need to square that. So it'd be 3.14 times 12, and actually this is inches squared, so that would give me 144 inches squared. Okay, and this is just the unit of measure here, inches squared. I'm not squaring anything else. And when I multiply 3.14 times 144, I'm going to get 452 and 1/1600 inches squared. And that would be the area of that circle. Now over here I have a true cutout problem. I want to find the area of this shaded region. I'll call it a donut. Okay, and what you need to do is you need to take the area of the big circle and subtract the area of the little circle from it. Okay, if this is the shaded in circle, and if I subtract the little circle, what do I'll be left with the area of my donut. Okay, that's what happens here. Okay, see, we take the area of the big circle, and then I find the area of the little circle, and if I subtract it, if I take it or cut it out, I'm left with my donut. Okay, let's do that mathematically now. Now first, it says that the diameter, I hope you can read this, you can read it on your paper better than on the screen. It says the diameter of the inner circle, that means from here to here, straight across through the center point, is 18 inches. Okay, it's 18 inches. And then it says the distance between the inner and outer circles, right here, okay, that would be another 3 inches. Okay, so if that's the case, the area of the big circle, okay, first of all, let's be careful here. If this is my center point right here, from here to here is what? 9 inches. A lot of people want to take 18 and add 3, get 21. No, 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 no. Okay, we're using area is equal to pi r squared. Okay, the radius, okay, the radius of this little circle from here to here is 9. And if I go all the way out here for the large circle, this is the big circle here, it's going to be 12. Okay, the radius is 9 plus 3 is 12. So I'm going to get 3.14 times 12 squared. That's my area. And I just did that not too long ago. So 3.1, because I know that this is going to be 144, it's going to be 3.14 times 144 inches squared. Okay, and that will equal 452.16 inches squared. Okay, that's my area of the big circle. Now the area of the little circle, once again, area is equal to pi r squared. Pi is approximately 3.14 times my radius, the radius of the little circle. It's not 18. 18 is the diameter. The radius is 9 inches. Okay, and what I get is I get 3.14 times 81 inches squared. 9 times 9 is 81. And 3.14 times 81, let me see, that is going to be 254 and 34 hundredths inches squared. That is the area, okay? That's the big, this is the little circle. So now I have to subtract the little circle from the big circle. Here's my big circle. I subtract the little, 254.34 inches squared. And what do I get? 6 minus 4 is 2. I have to borrow. 11 minus 3 is 8. Borrow again. 11 minus 4 is 7. Borrow again. 14 minus 5 is 9. 3 minus 2 is 1. So there's my answer. The area of the ring, okay, of just that donut ring, the shaded region, is 197 and 82 hundredths inches square. Boys and girls, let's look at numbers 6 through 9. We're not going to do all of them, but let's, for example, take a look at number 6 here. Now, number 6 says 1 square foot equals how many square inches? Well, what I would do is I would actually take the time to draw a little illustration. Okay, I've got my square foot here, right? Okay, and if it's 1 square foot, that means it's 1 foot by 1 foot. Okay, so the area would be 1 foot squared. But if I were to go by inches, okay, 1 foot is equal, oh my, sorry about that. 1 foot is equal to 12 inches by 12 inches. So this would also be equal to 12 inches by 12 inches, which would be 144 inches squared. Okay. Let's take a look at number 9. I like number 9 here. Number 9, okay. I've got 36 square yards. How many square feet is that? Well, what does that mean? That means I've got 36 yards square. Okay. Now, what dimensions would give me 36 square yards? Well, it would have to be 6 yards by 6 yards. There could be some other combinations, but that's good enough. It's 6 yards by 6 yards. And, okay, so if I have 36 square yards, I could have probably dimensions of 6 yards by 6 yards, which I know that 1 yard, okay, would be 3 feet. Okay, so 6 yards would be 3 times that, would be 18 feet by 18 feet. So I'd have to take 18 times 18, 8 times 8 is 64. 8 times 1 is 8 plus 6 is 14. Put a 0 there. 1 times 8 is 8. 1 times 1 is 1. We add this up, we get 4. And then we get 12, 324. So that would be 324 feet squared. Okay, let's take a look at number 10 here. 10, we have a fun one. We've got a find the area of the shaded region, and the shaded region is a partial region of a rectangle, okay? What we have here is we have a rectangle that is 3 circles long. Yes, I said 3 circles, not 45 centimeters long, because that's important. It's 3 circles long, and each of these circles then would have to be, since each of these circles is equal in size, each one would have to be 15 centimeters in diameter. 15 centimeters in diameter, 15 centimeters in diameter. Okay, which is very helpful because that then would also tell us the height, okay, because the diameter is the same this way, so the height of this rectangle would be 15 centimeters. Okay, now I can find the area of my rectangle. Okay, so I've got, okay, so area is equal to base times height. My base is 45, my height is 15, and they're both centimeters. So when I take 45 and multiply it by 15, that's going to give me 675 centimeters squared. Now that's the area of this whole rectangle, but we just want the shaded region. So what I need to do is I need to cut out each of these circles. That starts, so if I can find the area of one circle, I can multiply it by 3 because these 3 circles are the same, then I can subtract that from the rectangle. So my area of each circle is pi r squared. Pi is 3.14 approximately. My radius would be half of 15, which is 7.5 squared. Okay, so if I take 7.5 and I square it, I'm going to get 56.25 centimeters squared. And if I multiply that by pi, which is approximately 3.14, I will get 176.625 centimeters squared. Okay, so that's the area of just one circle. But I have 3 of these circles, so I would have to multiply that by 3. And if I multiply the area of one circle, oh, get out of here. Okay, sorry about that. So if I multiply this by 3, I'm going to get 529.875 centimeters squared. So that is the area of all 3 circles combined. Now I can subtract that from the area of my rectangle. Okay, my rectangle is 675 minus 529 and 875 thousandths. Okay, I'm going to have to do some major regrouping here. This is going to go to 9, 9, 10. 10 minus 5 is 5. 9 minus 7 is 2. 9 minus 8 is 1. 14 minus 9 is 5. 6 minus 2 is 4. 6 minus 5 is 1. So, my final answer is 145 and 125 thousandths centimeters squared. That's the area of the shaded region. Well, boys and girls, as always, I hope that was helpful, and if you have any questions, please bring them to class tomorrow. I'll see you then. Bye-bye.